Hello, welcome to Chapter 8, homework questions 69 through 75. Question 69. Use a similar process as you did in problems 65 and 67 to sketch the parabola y equals x squared plus x minus 6. So going back and looking at those questions, we are going to be using the intercepts. We have to find them, and then we will sketch our graph with those three data points. So the first thing we need to do is to find the x-intercepts. Remember, that's when y is equal to 0. So we can set 0 equals x squared plus x minus 6. And to be able to do this, we need to write the trinomial as a product. So you guys can show your work on how to do that. I'm just going to go ahead and write the factors x plus 3 and x minus 2. And now we can use the zero product property to set our factors equal to 0, because if two things are being multiplied to give you 0, one of them must be 0. And so that gives us two x values. When y is 0, x is negative 3. And when y is 0, x is 2. And now to find the y-intercept, this one's a little bit easier to do, is when x is 0, what is the y value? So we plug 0 in for the x's, and then we simplify. So you can see all that cancels out and leaves you with y equals negative 6. So the y-intercept is 0, negative 6. So let's go ahead and plot these points. There's 0, negative 6. And then we have negative 3, 0, and 2, 0. Now, with only these three, we don't really know where the max and min and everything else are, so we're just going to graph it based on this information. You could also look, though, at your intercepts, and the middle is going to be approximately right there at negative 0.5. So we do know the parabola will be at its minimum point there, so we can kind of use that to help us out, but all we're doing is sketching, so we know we're not going to hit all the points as accurate as we would like. But that's how 65 and 67 did it from the core problem. So we have the intercepts, and then we graphed the best we could. Question 70. Compare the two equations below. So you have the first one, x plus 2 times x minus 1 is equal to 0, and then x plus 2 plus x minus 1 is equal to 0. How are the equations different? Well, the operation. In between the two parentheses, when there's nothing there, that means we are multiplying. But in between these two parentheses, you see the addition sign. So that's how they are different. All right, and then on part B, solve both equations. So we have x plus 2 times x minus 1 is equal to 0. And since it's equal to 0 and it's already factored, we can now use the zero product property to set both factors equal to 0 to find our two values of x when we're solving. So x is equal to negative 2 and x is equal to 1. And so we can write that, or if we want to write it as a set, we can do x equals the curly bracket and then negative 2, 1. Either way is fine, though. And then on the second equation, we have x plus 2 plus x minus 1 is equal to 0. So this one, we can just add the 2. X plus x is 2x. 2 minus 1 is 1. And now we can isolate the x by subtracting 1 and then dividing by 2. X is equal to negative 1/2. So you can see the first problem is a quadratic, and we're getting two values of x that cross the x-axis. And then the second one is linear, and that's why we only get one solution. Question 71. For each equation below, solve for x. So now they're already in factored form. So we can just jump right into the zero product property and solve for each of those. So we'll set them equal to 0. X minus 2 is equal to 0. So one of the solutions is x equals 2. And x plus 8 is equal to 0. So the other solution is x equals negative 8. So x equals 2 or x equals negative 8. Or once again, if you do want to write it as a set, x is equal to negative 8 comma 2. But you have to use the curly brackets. You can't use parentheses. It'll look like an ordered pair. So on to B. We have 3x minus 9 and x minus 1. Set your factors equal to 0 using, once again, the zero product property. add 9, divide by 3, x is equal to 3, and then x minus 1, we just add 1, and we get 1. So x is equal to 1, or x is equal to 3, or x is equal to 1, or 3 written this way. All right, on to C. We have x plus 10. 2x minus 5 is equal to 0. Set our factors once again equal to 0 using the zero product property. Get one answer of negative 10. And then the second one, as we add 5 to 0, we get 5. And then divide by 2. And x is equal to 2.5, or 5 halves. All right, and on to D. Now this one has x minus 7 squared is equal to 0. But remember, that is x minus 7 times x minus 7. So we actually have the same factors, which means we're going to get the same solution. And x is equal to 7. Now why the repeat? Well, because it is a quadratic. And if we are solving for x, we're finding the x-intercept, so this means that at x equals 7, the graph must not cross it, but somehow just touch that one point since it doesn't have two solutions. Question 72. Examine the system of equations below. Before solving this system, Danielle noticed that the point of intersection is also the y-intercept. Explain how she knows this. Well, if you look at your two equations, this equation at x equals 0 is going to be a vertical line because it doesn't have the slope, and it's going to be a vertical line through 0, which is the y-axis. So at x equals 0, you have your vertical line, which represents the y-axis as well. So if that's the case, no matter where that line intersects, it's going to intersect at the y-axis, which means it will also be the y-intercept of the first equation. All right, and then part B, find the point of intersection of the two rules from above. So we could just plug 0 in, because since we know what the x value is, and if you think about that, if you're plugging 0 in for x, that's what you're finding, is you're finding the y-intercept. So we get negative 2y equals 4, divided by negative 2, and y is equal to negative 2. So therefore, the point of intersection would be 0, negative 2. Yes, it is the y-intercept of 5x minus 2y equals 4, and we plug 0 in to do that. The x-intercepts of the graph of y equals 2x squared minus 16x plus 30 are 3, 0, and 5, 0. What is the x-coordinate of the vertex, and how do you know? Well, if we're looking for the vertex and we have the intercepts, it should be the midpoint, or in the middle of those 2 points. So if you're at 3, 0 and at 5, 0, what's the middle point? Well, that would be at 4, something. You're 1 unit away from both of them. All right. The other way that you can find the middle of two numbers is to add them up and divide by 2. So 8 divided by 2 would be 4. So if the numbers were a little bit farther apart, that might be helpful. So what is the x-coordinate of the vertex? The x-coordinate is 4. From what we just had talked about, it's the middle because of the symmetry of a parabola between the x-intercepts. So once again, since the vertex lies on the line of symmetry, it must lie halfway between the x-intercepts. And then on part B, it wants us to go ahead and find the y-coordinate of the vertex and write it as a point. So if we know the x value is 4, then to find y, we should be able to plug 4 in for x and solve to find your y value. So this would be 2 times 16 minus 64 plus 30. So 32 minus 64 plus 30 would be y equals negative 2. So the vertex is at 4, negative 2. Question 74. Factor each quadratic below completely. So on the first one, if you recognize, there's a 2 in common. So we're going to factor that out first, and that'll leave us with x squared minus x minus 2. And then we can factor the rest of it, once again, by using the generic rectangle. We have our x squared, our minus 2. We can use our diamond. Remember, the product has to give us negative 2x squared, but it has to add to give us negative 1x. And so that would be negative 2x and positive 1x. Multiplies to give you negative 2x squared, but adds to give you negative 1. So we can put those in the correct spots, and then we know that x times x gives us x squared, x times negative 2 gives you negative 2x, and then x times 1 gives you 1x. So it looks like we will have 2 times x minus 2 times x plus 1. And on part B, once again, we have a common factor of a 4. So we'll factor the 4 out. And that'll leave us with x squared minus 6x plus 9. And then we can use our generic rectangle again. We have an x squared and a 9. And we need to know what multiplies to give us 9x squared but adds to get negative 6x. And that will be minus 3x, or negative 3x and negative 3x. This is also a perfect square trinomial, so if you were able to do it by using the shortcut, that was great too. So this is negative 3x and negative 3x, which means we have an x times an x, a negative 3 and a negative 3. It's supposed to be a 3. And so now we have 4 times x minus 3 times x minus 3, or x minus 3 squared. Question 75. Rewrite the following expression using fractional exponents. So in part A, if we're raising it to the third power, and inside it's the square root. So the square root we can rewrite as 3x. And since the whole thing, the 3 and the x are being is underneath the radical, then it's 3x in parentheses raised to the 1/2. And then all of that is being raised to the third power. So we can simplify that so that it is 3x, and then 3 times 1/2 is 3/2. And once again, it wanted a fractional exponent, so I think that's all we need to do. On B, you have 81. It is the x root of 81, so 81 raised to the 1 over x. And we don't know what x is, so that's as far as we can go on that one. And once again, it's written as a fractional exponent. And then on C, we have the cube root of 17 raised to the x. So we can rewrite the cube root of 17 as 17 to the 1/3. And then all of that is raised to the x. So that simplifies to 17 raised to the x over 3. You multiply the 1/3 times the x. And so all 3 of those are written as fractional exponents.